Ranger 2, prepare to detach.
What? No! No! Cooper!
3.
Cooper, what are you doing?
Newton's third law. You gotta leave something behind.
Hello, Mustafa. So this is from 2021 paper 2, question 4. I remember this question is quite tricky, actually. So let's have a look. So figure 10 shows a conveyor used to raise concrete blocks on the building site. Blocks do not slip on the belt at any time, so they're raising it up. Okay, so figure shows an enlarged view of one block on the belt. The belt is inclined at 23 degrees to the horizontal. So it looks like an inclined plane. Maybe we're going to do some mg sine theta. In fact, I'm going to sketch it already. So there's 23. That's mg sine theta. We may need to use it. We never know. This is mg. They told you the block is 19 kilograms anyway, so maybe we're going to use that. Okay, so draw an arrow on the figure to show the line of action of the force. Oh, sorry. The belt exerts an frictional force on the block when it's at rest. So when it's at rest, mg sine theta is downwards, and you've got a force upwards of F, which is the frictional force stopping it sliding down. Probably make sure you're joining it to the block. Okay, so let's have a look then. So show that the magnitude of F is approximately 70 newtons. So yeah, so F, force upwards, must equal force downwards, which is mg sine theta. Why is it equal? Because it's at rest. The sum of the forces or resultant force is 0, Newton's first law. So let's just put your numbers in. So what was the mass? 19. So 19 times 9.81 times sine 23. So that gives you 72.8 or 73 newtons. So I guess you could argue it's approximately 70 newtons. So the belt is driven by an electric motor. When the motor is switched on, the belt and the block accelerate uniformly from rest to a speed of this in a time of that. Calculate the magnitude of the frictional force on the belt. Okay, so what do we know? We can work out the resultant force is equal to ma because it's speeding up. So 19 times v minus u, well, v minus u is 32 over 0.5. Okay, so let's just put that in. Sorry, I forgot to put the 0.32. Would have lost the mark there. So when I put that in, I get 12.16. So that's the resultant force. Okay, so what's the force from the belt? Now, the belt has to, first of all, overcome the mg sine theta. So therefore, it's actually F minus mg sine theta is equal to this MA, so 12.16. So you can work out F, you just got to add the 70 to this, so plus, or 73 rather in my case, 73. So that gives me 85.2 newtons or 85 newtons. So this must be the force from the belt when it's accelerating upwards. Because when you subtract the 70, that will give you your MA. So that's not too difficult. So now let's look at the next bit. So the motor is connected to a 110 volt DC supply that has a negative internal resistance. Maximum operating current in this is that. So from them two, I can work out the power, which is simply IV. So 110 times 5, which is 550. So I'm going to just do some calculations anyway. The efficiency of the motor and drive system of the conveyor is 28%. So that's the input. So what's the output? So the output is 550 times 0.28. So 550, 0.28. So that gives me 154 watts. Okay, so that's the output power that's helping to raise these blocks. So the belt travels at 0.32 meters per second, 8 meters long. So this is now the constant speed that it's got itself up to. Deduce the maximum number of blocks. Okay, so what do we know? This is a constant speed. So what does that mean? It means the resultant forces on the block are equal. So what have you got downwards? You've got mg sine theta. So the force upwards must be equal to that at constant speed. It's not accelerating anymore. Okay. So therefore, because you've got a constant force with a constant speed, I can use power equals Fv for one block. So that would be the 73 from before. So 73 times by 0.32, because that's the constant speed. Right, so if I put that in, 73 divided by 0.32, so that gives me, sorry, times by 0.32. So that gives me 23.36 watts. Now, the output power is 154. So this, don't forget, this is for one brick. Okay, so total number of bricks, just divide the output, total output by this number of bricks is equal to 154 over 23.36. So 154 divided by answer. So that gives me 6.6. So how many blocks? It's going to be 6 blocks or 6 bricks. Hopefully that helps. Bit of a tricky question, especially the last bit. The last bit you got to realize is moving at constant speed again. Okay, because it did accelerate for a short while up to this speed. And the way you'd have probably got muddled, you'd have probably thought it's still accelerating. So you're thinking constant, a resultant force. You could have actually done it via energy. Okay, so you've got I and V, and because current and voltage, and because of this V and this S, you're probably thinking, where do we use this? You can actually work out the time from that. Okay, so you could have actually done IV2. So you could have used energy instead of, because I've used the efficiency in terms of power, output power, input power. You could have used it as output energy, input energy, but that's up to you. Okay, so if you times, but that would just, you'd have got the same mark anyway. Okay, so is it worth it? It depends which way your brain thinks. As soon as I saw power, I started using the power way. It's just convenient. The power equals 4 times velocity pops up there for me. Okay, so that's how I would do it. Yeah, just to add, like I said, if you work out the IV and then do 0.8 over 0.32, you can work out the time. So you got IVT for the energy. Then work out the output energy, just times that energy by 0.28, and then you could work out the energy output by doing force times distance. So, and then once you've done force times distance, you've got the energy for one block, and then just do the output energy over the energy for one block. Again, like I said, the power way is the most obvious one I would do. Okay,